Welcome to Plutus Project-Based Learning 2023 from Gimbal Labs. Thank you for watching this video. We're currently working through Module 202, 5 Ways to Mint a Token. We've looked at 3 ways so far, and so now it's time for number 4. Let's mint a native asset using a Plutus minting script compiled from Plutus TX. At a high level, we'll cover 2 key steps in this video. First, how to compile a Plutus minting validator script from Plutus TX. And then we'll use that script to build, sign, and submit a minting transaction. Along the way, we'll be making connections to previous lessons. In lessons 101.3 and 101.4, you saw how to run a Plutus TX project for the first time. Maybe it was in Demeter Run, or maybe you have a local development environment running. In lesson 202.2, you saw how to mint tokens using an included shell script, and we'll use a similar script in this lesson. I hope that this video helps you continue to build up your background knowledge about the different parts of Cardano development. You can follow along with the documentation below this video. Let's take it step by step. You might be working locally on your own device, or you might be using Demeter Run. Either way, make sure to navigate to the PPBL 2023 Plutus template directory and run git pull. In this video, I'll be working locally, but if you run into problems on Demeter Run, make sure to bring them to live coding. Here's my code editor, and in my PPBL 2023 directory, I have the PPBL 2023 Plutus template. Let's change into that directory and just run git pull to make sure that you have the very latest changes. You might have already done this in lesson 202.2, but it's always good to make sure you're up to date. I've already mentioned that I'm using a local development environment, but once again, you can follow along with lesson 101.3 to run the Plutus template in Demeter Run, or you can follow along with lesson 101.4 to run the same repository locally. Now let's use it. If you're using Demeter Run, you'll simply be able to run Cabal REPL and move on to step 3. If you're working locally, according to the steps outlined in lesson 101.4, the first thing we'll need to do is run Nix shell in our Plutus apps directory, and I just note that we're still using the v1.1.0 checkout of Plutus apps. Let's take a look at how this works. I'm going to navigate out of my Plutus template directory and into Plutus apps. You might have Plutus apps stored in a different place on your computer, so just change directories accordingly. And I can run git status just to make sure I'm on the correct branch, v1.1.0 in this case. This is not the newest version of Plutus apps, but it is stable, and it's reliable enough for us to learn on right now. When I run Nix shell on this computer, I happen to need to use this gc-don't gc1 tag. And of course, if it's the first time you're running Nix shell on this checkout of Plutus apps, it'll take a bit longer the first time. Now we see that I've successfully loaded Nix shell. And so now I can navigate back into the PPBL 2023 Plutus template that I just updated a few moments ago. Now, because I have the latest changes pulled down, I can simply type Cabal REPL to load the REPL. You can see that it just worked pretty quickly for me because I've done this already. If you're doing it for the first time, it always takes a little bit longer because remember, you're installing a whole bunch of packages as specified in this project. With the REPL running, I can move on to step 3, and I'll see that in my terminal window, the prompt looks like this, always succeeds.compiler. You can see that here. For this lesson, I don't actually want to use the always succeeds compiler. Instead, I want to use a different one. I want to use the tokens compiler. Let's take a look at how this project is constructed so we can see where this is coming from. The first thing I can see if I open the source directory is that there are two subfolders, Always Succeeds and Tokens. Now, inside of Always Succeeds, there's a file called compiler, which is why we can have always succeeds.compiler right here. Additionally, in the .cabal file for this project, we can see down below that there's a list of exposed modules. Here, I can see that always succeeds.compiler is first in the list, and that's why we can see it loaded in my REPL. But what I'd rather use is the compiler for a tokens script, and you guessed it, that file is defined right here, tokens.compiler. Because we have this folder structure and these exposed modules, I can load any of them. So, for example, I could load, that's a colon and a lowercase l, tokens.minter. And you can see, here it is, loaded. But of course, what I really want to do is compile a Plutus script. So I'm going to load tokens.compiler. And there you can see, tokens.compiler is now loaded. Once I can see this prompt, I can run write Plutus minting script. And the way the REPL works is if I start to type the name of this function and press tab, it auto-completes. That's a good sign. That means everything is working like it's supposed to. Let's run it. You can see that I get this message. It says, write. That means it ran successfully. And you can see in my output directory, there's a new Plutus script file called mint.plutus. It looks like this. And if this step worked, congratulations, you just created a minting policy script with Plutus. Way to go. This script can be used exactly like the native script you created in lesson 202.2 to mint new native assets. Before we take a look at that, let's take a quick look at the Plutus TX code that's making this possible. In the documentation, you can see the two main parts I'm about to show you, but let's jump back to the code editor to take a look at these entire files, tokens/minter.hs and tokenscompiler.hs. I'll open tokens.minter first. It's not a very long validator. We're actually initializing a little bit more than you need right now, but this is for later convenience. The key thing we want to look at is right here. This is where our minting validator is defined. Everything that comes after this make policy statement is boilerplate, and in many cases you won't have to change these lines. What's interesting is how we define the Boolean for this minting policy. Remember, a Boolean is just a true or a false statement, and if the statement is true, this validator will allow tokens to be minted. Otherwise, it won't. So what statement has to be true? This one right here. It says _redeemer equals, it looks like the golden ratio times about 1 billion. Now, the redeemer is defined here. It's an input to this minting validator. And in the type signature on the line above, we specify that the redeemer must be an integer. It doesn't have to be an integer. And Plutus gets a lot more interesting when we start using more complicated data types for our redeemer. But this is a simple example to get you started. And when we build a transaction to mint these tokens, you'll see how the redeemer is used in the minting transaction. Let's take a quick look at the compiler. The main thing I'd like you to see is that we just used this write Plutus minting script function in our REPL to create a file in the output directory called mint.plutus. You could change this file name to whatever you'd like. Now, if you got an error when you first tried to run this function, it might be because your output directory doesn't yet exist. Be sure to make it. Finally, A quick note on where that word right comes from, if everything works. That's from right here. This either statement has a left-hand set of purple parentheses and a right-hand side. Notice that on the right, it's just a unit. So if this function runs correctly, we get right. And if there's an error, which if you haven't seen it, you can recreate by just deleting your output directory, and you can see for yourself. If we get an error that this directory doesn't exist, it'll be preceded by the word left and then a written description of the error. Is there more to talk about with Haskell and Plutus? You bet there is, but I hope that this example is just giving you some context for how we can start to create scripts. Let's look at the rest of the pipeline. What follows the compilation step? Well, after I have a compiled Plutus script, I can use it in a transaction. And that's what we'll do next. Now that I have my Plutus script, I can exit the REPL and I can exit Nix shell. I won't be needing those unless I want to recompile this contract with other values, and you might choose to do that later. But for now, let's use Control-D to exit the REPL and to exit Nix shell, like this. You can see I'm still in the REPL, so I'll press Control-D, and you can see I get the message, leaving GHCI. Now I'm still in Nix shell, so same thing to exit that. Control-D, and now I'm back to the Plutus apps directory, where I initially launched the Nix shell. Finally, I can navigate to the same bash scripts directory that we were using in lesson 202.2. This time, we're going to use the file mint tokens plutusscript.sh. This is a shell script. And it's really similar to the script we were using in that previous lesson, the native script file, with only a few key differences. Look at Cardano CLI transaction build. There's two important lines I want you to notice first. There's this one, TX in collateral. Because we are working with a Plutus script now, we must specify a collateral UTXO. Then these three lines look pretty much the same as in the previous example, but they're followed by this new line right here, mint redeemer value. And you can see we're using the variable secret number. I bet you can figure out what it is. I'll leave it to you to review the rest of this file right here. And I hope if you have questions, as always, you'll bring them to live coding. There's a lot more we could look at here. For now, let's just try to run this script and see if it works. I can navigate to my working PPBL 2023 folder, where I have the PPBL 2023 Plutus template once again. This is the same directory that I was just navigating in my Nix shell, and from here, this is where I ran the REPL. But it also has a subdirectory called bash scripts, and inside, you can see the script we're looking for, mint tokens Plutus script. Now, I made a mistake in the previous video. I still had Z shell running on this computer. I've fixed that since then, so it's working a bit better. And if you're a Mac user and you run into the same problem, there's some links now provided in lesson 202.2. Now I should be able to run this script without error because I'm actually in a bash shell and not a ZSH shell. If I just try to run this script, I'll get a little error message right here that says usage. I must provide the path to a wallet directory. That's a good thing, and that's written directly into the top of this script. You can find it. Let's try it again. And this time, let's specify the path to my PPBL 2023 example wallet. You'll be guided through a process that's similar to what you saw in the previous lesson. I'll mint from this address. Yeah, that sounds good. And now I have to enter the path to my Plutus minting script. That's actually in the same parent directory as the bash script I'm using right here. So I'm currently in the bash scripts folder. I want to access this outputs folder, and this mint.plutus file. So let's just go up one directory, then into the output directory, and finally specify the file mint.plutus. This will now be the script that's specified right here, okay? I can mint these tokens to myself. Keep in mind, you could send your tokens anywhere. And once again, I can name these tokens whatever I'd like. Let's call them scaffolds. And I'll just mint 12 of them for now. Now I get to a new question. It says, enter the secret number. Whatever number I type right here is going to be stored as the variable secret number. And it's going to be passed as the redeemer to this minting script file. In order for this transaction to work, or in order for it to be valid, this secret number must match the one defined in our minting validator. In this case, it's this number right here. Let's try it. I get a confirmation message that says I will mint 12 scaffold tokens with this policy ID. This policy ID is generated in the script file, and I encourage you to look for where that happens. It's very similar to the script we looked at in lesson 202.2. And finally, I just have to choose a UTXO to serve as both the source of fees for this transaction and to play the role of collateral. UTXO number 4 has plenty of ADA in it and no other tokens, so I'll use that one. With that step complete, I get a message that says minting. I can see that the build step worked because I have this estimated transaction fee message. And then finally, I can see that the transaction was successfully submitted. Note this transaction fee right here. We're going to talk about this later. After I wait a few minutes for the transaction to be confirmed on chain, I can query the address that I just used in this transaction. And let's see if I can see my 12 new tokens. This looks good. Here they are. And by the way, notice that this transaction hash matches this one right here, because these are the two outputs of the minting transaction that I just built. You can also see that unlike in the lesson 202.2 video, the provided script is working on this device. And you can see that there's a token name right here. That's scaffold in hex. As always, there's a lot more to talk about here, so I hope that you can use this exploration to start getting familiar with how Plutus minting policies work. But there's plenty for us to talk about at Live Coding. One of the things I would love to do is to look at some errors. We can try to build some transactions that don't validate. And maybe you can try this on your own. Thanks for going on this journey together, and see you soon.